The miners disappeared. The machinery fell silent. Roads surrendered to grass, desert, and forest, and in some places, entire communities vanished so completely that only empty buildings, collapsed shafts, rusting equipment, and forgotten names remain. But there is something these abandoned towns could never take with them: the geology. Across the world, settlements were once built almost overnight because somebody discovered gold nearby. Thousands arrived, mountains were opened, rivers were diverted, fortunes were made and lost. Then the richest ground became harder to work. Mines closed, people left, and nature slowly began taking the towns back. But here's the question: did those miners actually recover everything? Not necessarily, because the prospectors of a century ago were working with different equipment, incomplete geological knowledge, and in some cases were pursuing only material profitable enough for the technology of their time. That doesn't mean every abandoned gold town still contains recoverable nuggets, but it does mean these landscapes can teach us something incredibly valuable. They show us where gold occurred, how miners followed it, and what geological patterns led people there in the first place. So today, we are not entering abandoned buildings looking for treasure. We are doing something much more interesting. We are traveling around the world to 10 historic gold settlements and reading the landscapes that surround them. From the forests of New Zealand to the mountains of South Africa, through Canada's old gold rush country, across Montana, and finally into the immense Australian goldfields. At every stop, there is one simple prospecting lesson, one clue, one technique, one way of looking at gold-bearing terrain differently. And the first town is perhaps the perfect place to begin, because hidden among the forests of New Zealand's South Island is a settlement of gold in a drainage. The beginner becomes excited about that exact location. They keep searching the same gravel. The more experienced observer looks uphill. Which tributary enters here? What rock does it drain? Does the gold become coarser in one direction? Does its shape change? Is it heavily rounded or relatively angular? Transport changes gold. The farther a piece travels through an energetic stream, the more opportunities it has to become flattened, rounded, folded, and mechanically worn. Coarser or less worn gold can sometimes suggest a closer relationship to source, although real placer systems are complicated and no single piece can prove where that source lies. That is why the technique is not find gold and run uphill. It is build a trail of evidence, sample carefully where legal, compare tributaries, study the geology, watch how the character of the heavy material changes. See, because placer gold is not simply treasure, it is information. Every particle has traveled from somewhere, and somewhere around Waiuta, miners discovered where that journey began. The surrounding region still preserves numerous historic sites associated with quartz gold mining. But our next landscape turns that relationship almost upside down, because farther south, another New Zealand settlement became associated with gold not merely in hard rock, but in a landscape shaped by water. 2. Urapuki, Southland, New Zealand. Technique learned to recognize previously worked ground travel. South toward Te Waiwai Bay and the scenery changes. dense forests rise behind rolling country. The ocean appears beyond the land, and beneath the quiet landscape sits Orapuki. Today it is tiny, but during its mining era, the settlement grew to roughly 3,000 people. Evidence of old gold working, including sluicing scars, remains part of its historical landscape. Those scars teach our second technique. Most beginners see old workings and think, someone already searched here, move on. A trained observer asks something different. What exactly were they searching? Historic workings can reveal the geometry of a deposit. Look at where miners concentrated their effort. Was material removed from attacks that rock. Fractures widen, pieces break free. Gold becomes liberated. Gravity moves material downhill. Seasonal water carries it into drainages. Now imagine standing in a stream below known historic lode workings. You already possess information the river alone could never give you. There is a documented gold source somewhere upstream. The question becomes, how would erosion connect that source to this drainage? Look at side gullies. Look at steep slopes entering the creek. Look at where tributaries draining mineralized terrain join the main channel. Then study where the stream loses energy. The goal is not simply to find a beautiful-looking bend. It is to connect source, transport, and trap. This is one of the most powerful ways to stop prospecting randomly. A bedrock crevice is interesting. A bedrock crevice in a drainage connected to known gold mineralization is more interesting. Add heavy mineral concentration. Add favorable stream geometry. Add documented placer history. Now several independent clues begin pointing toward the same conclusion. That is how geological reasoning becomes practical. But the next location teaches us what happens when a gold rush becomes so powerful that an entire valley fills with thousands of people almost overnight. For that, we travel to Africa. 4. Pilgrim's Rest. Mpumalanga, South Africa. Technique. Read tributary junctions. The mountains of Mpumalanga are green. Deep valleys cut between them. Streams descend through forested slopes, and among these mountains sits Pilgrim's Rest. In 1873, news of a rich strike helped trigger South Africa's first major gold rush. By the end of that year, around 1,500 diggers were working thousands of claims in and around the area. Gold discoveries were associated with several surrounding gullies and creeks. That geography gives us our fourth technique. Pay attention to where streams meet. A tributary is not simply additional water. It is an entirely different sediment supply. Imagine the main creek carries little gold. Then a smaller tributary enters from a mineralized hillside. Suddenly, the geological is far below. Those rocks are telling you something. Water once occupied that elevation. Economics changed, people moved away, roofs collapsed, vegetation returned. Desert winds crossed empty streets. And eventually, the silence came back. But geology does not recognize ghost towns. A fault remains a fault after the last miner leaves. A mineralized structure does not disappear because a mine closes. An ancient channel does not forget where water once flowed. And gold trapped deep inside bedrock does not know whether the town above it contains 10,000 people or nobody at all. That is why the greatest lesson from abandoned gold country is not go back and search where the old miners searched. It is something much more useful. Learn why they searched there in the first place. Because once you understand that, you no longer need a ghost town. You can stand in unfamiliar country and begin asking the same questions. What is the source? Where did erosion move the material? Which drainage carried it? Where did the water slow? Where did bedrock trap it? What did the old river look like? And what changed afterward? That is when prospecting becomes something different. Less like gambling, more like reconstruction. You are rebuilding a journey that may have started millions of years before humans existed. A journey from rock, to slope, to water, to gravel, to bedrock, and perhaps eventually to your hand. The abandoned buildings are only the beginning of the story. The landscape is where the real evidence remains, and somewhere beyond the last collapsed mine building, beyond the old road, beyond the creek the first prospectors searched, there may still be another piece of that geological story waiting to be understood. Not because the old miners were foolish, not because every ghost town hides forgotten treasure, but because no generation of prospectors has ever had the ability to examine every fracture, every buried channel, every meter of bedrock, and every piece of ground surrounding a gold system. The towns became ghosts. The geology never left. Geology